Hey, this is Loud and Gaming, and it's been a while since I've made a video for my channel, and decided that I want to kind of do some programming type of challenges and just kind of program and maybe share that with everybody. And one thing that I've been kind of thinking about is a kind of sand simulation. Where you have like pixels and they're falling and they create like mountains of sand, and then maybe you can sprinkle some water, and then you know the water's moving around, it's acting kind of like water. Maybe you've seen these in different maybe video games. I know there's a really complicated one on Steam, whereas like everything's just made of these tiny pixels and particles and all this kind of stuff. So I thought, well, maybe I could do this in Unity, and how would I go about it? And I'm trying not to, look at anyone else's code, but try to just how would I do it? How could I make it? Now, I have watched a few videos and read a little bit about how it actually works. So here we have like a grid, and let's say this grid has the sand here. Let's pick this color, and it has the sand in this spot right here. And what the sand would do is maybe look at the tile or the grid below it. And if it's empty, then it would just move to that next location right here. And then it would look at the next one. So every frame just looks for the next one and it falls down. But if there's already something there, so if this grid right here was already filled with something, then the sand would maybe look here. And if that was empty, then it would, you know, go into that spot. And then it would kind of continue, down the path, you know. Or if that one was that space was taken, then the sand would, you know, go over here. Look over to the one to the right below it. And then it would go down. All right, so that's what we're going to try to do. So let's go back to Unity. All right, so here back in Unity, we have our scene here, and let's add. We're going to add a quad. All right, now what we're doing here is, I know Unity has like game objects, but that might not really be the best way to um, do this. What I'm thinking of doing is to actually take a texture and um, painting the pixels on the texture instead of having like a bunch of game objects and using the game objects to kind of drive the system. We're just going to uh, change the pixels on a texture. All right, so let's go to some scripts, and I'm just going to create a few scripts here. All right, so this cell class, we're going to get rid of the model behavior. It's not going to be attached to any game objects. And we can get rid of all that. And we're going to define a few variables, I guess. Public vector2 int, and we'll call this the position. And let's see, we want to have some variable type, so let's do a public enum, and okay, public enum. We're going to call this cell type. All right, and we could say none, which I probably won't use that, but we'll just have that just in case. And we'll just for now have sand, and we'll eventually probably have water. All right, so that's all we're going to have for now. We might add more to that. All right, so here we have a class called the simulation. So this is basically going to manage all the simulation. We are going to have a public we're gonna make this a singleton. And so we'll have a public, we'll call it static, simulation, we'll just call it instance. And then in our wake, we're just going to say instance is equal to this. There's some other code you could do to make sure that this was the only one. I'm not really going to worry about that. All right, so we want to also have a public, we're going to call this grid. And sorry, we need a public cell, and it's going to be a two-dimensional array, and we're going to call this grid. So now we just need to set that up, but I guess before we set that up, we can say uh, int width, let's just say it's 100, whoops, and int height is equal to 100. And so let's just set this grid up. We're going to say for y is to the height, for x is to the width, and we're going to just say, or actually what we need to do is grid is equal to a new cell of, let's see, width, comma, height. So this will set the dimensions there. And I don't know if this is necessary, but we will just do it. We're going to say this is they all equal to null. All right. So get that grid set up. All right, we are going to be using that update. Okay, so another thing we need for our cell is we're going to have now you can make this abstract. So if I make this abstract, that means, okay, did I not spell that right? Abstract. And basically this means that you can't make an instance of a cell, but we can inherit from that cell. But you don't necessarily have to, but it's fine. But we can say a public virtual. We'll call this the activate. And okay, I didn't want that. Sorry. Void activate activate. And what this method here will do is just this is where we'll have the logic for whatever cell we want. So basically the cell can be a sand or it can be water. Um, and then we will use the activate to kind of do the logic of how it's going to move in the grid. All right, so another thing we're going to do is we're going to have a public list. So instead of looping through like every grid, uh, every like going through each X and Y of the grid and seeing, okay, do you have a cell in it or not? If you do, can you just do the logic for it? That could slow things down if you have, more than 100 by 100. Uh, and so instead of doing that, because some of the grid won't have anything in it, so it really doesn't need to do anything. So we're just going to have a list of all the cells. So we'll say all cells. And this is everything that has been created in our simulation. So at the beginning, there will be nothing. And if we add one grain of sand, then the list will only have one in it. And it'll probably make things a little bit quicker. There's probably other ways that you can optimize this as well. But for now, we don't really need to worry about that. All right, so what we want to do is uh, for each cell we'll call it cell, in the all cell, we want to cell dot activate. Okay, so we're going to loop through that list and just activate, run the logic on whatever the cell might be, and then do its thing. All right, we want to have a public void. We want to add a cell. So something outside of this, we'll call this method for us to create the cell. We're going to send it a position and we'll send it a cell type. Now, this probably isn't the best way to do this. There might be better ways to kind of like create this, but this is just what I'm going to do for it. So we'll just use a switch. You might not like using switches, but um, it'll be fine. So we want to switch based on the cell type. And so based upon the cell type is what kind of cell we're going to actually create here. So after we get that, we're going to be adding that. Now, one thing I want to do is actually have another list and call it a cell. And we're going to say cells to add. And we're going to say new list. And the only reason why we might want to do this is let's say we're looping through our list right here. And while we're looping through this, one of these cells, part of its activation thing says, hey, I'm going to make a new cell. Well, when it does it, it's going to be adding it to this list, and that's going to give you an error because you cannot change your list while you're looping through it. So we're going to have this kind of, whenever we add a cell, we're going to add it after this. So let's actually say for each, and we're going to say cell. We'll do the same thing, or we can say add cell if you want to clarify that in the cells to add list. This might not be making sense, but we just want to kind of set this up first so that we don't have any errors later. So cells to add, and basically we are going to. Does this need to be a cell? No, this should be a cell. Yeah, cells to add. Yeah, that's fine. We're going to do that. Okay. So all we're going to do is just say uh, all cells. And I don't like that spelling. Let's change that to an S. All cells. We're going to say all cells dot add, and we're going to add this add cell. So that way, when we add a cell, we'll add it to the list after we've gone through our list and activated everything. And then what we can do is just clear out that add cell list. Add cell. I don't really like the spelling. Dot clear. Okay. Oh, that's because it's supposed to be called cells to add. Cells to add. And we can just clear that list. All right. So in our add cell, so right now this really doesn't do anything. So if I ran the program, it's not going to do anything. It just creates a grid. It's going to loop through all the cells, which will have none at the moment. And that's that. So let's go to another function we're going to want to do, which I'm going to call public void set position. This could probably be named something else. And what we want to send it, let's see, we want to send it a position, right? So a vector2 int position. And let's send it a cell. And let's send it a Boolean and say is remove isn't the best word for it, but I guess we could say is remove. So when we call the set position, what we want to do is remove the old position and uh, do the new position. Okay, so but sometimes we might not have the old position. Sometimes we may not want to remove the old position. So going back to like think about the grid when the sand moves down because we're using a texture and we're using pixels and we're not using actual objects. We need to like kind of erase the last position when it moves. And actually, before we do all this, let's actually do get our a renderer. So renderer. So this will be the renderer of the quad. Uh, we actually don't need that, but we do want a texture 2D, and let's call this the display texture. So we want both of those. Now when we start, we are going to say renderer is equal to get component, and we want to get the renderer that's attached to the game object where this simulation is going to be located on. So we're actually going to add the simulation script to that quad, and then it will get the renderer of the quad. And then what we want to do is actually maybe even before that, we can just say display texture is equal to a new texture 2D, and we want to send it the width and the height of our simulation. And then we want to say renderer dot material dot main texture is going to equal to the display texture. So we are changing the texture of that material that's on uh, the quad, and this texture is going to have a width and a height, and this is what we're going to be changing. Now, one thing for changing pixels on a texture, uh, we're going to be using the set pixel. But in order to actually see that change, you have to call a method on the texture 2D. And so we're going to say display texture dot apply. Now, this can be kind of expensive. So what we can do is we're going to first change any texture or any pixel that we need to change. That's all going to happen first. And it'll mostly happen in this loop right here. And then once when we change all the pixels, then we'll just call for one apply. And there might be a better way or a more efficient way to do this, but uh, this will work just fine for what we're doing. All right, now going back to the set pixel. So now we can kind of set these pixels up. Now, one thing we need to do, going back to the cell, let's have a public color and call it color so that every different kind of particle or whatever you want to call it will have a different color. So maybe sand will be yellow, water will be blue. All right, so if is remove, we want to take the current cell, that position, then actually we want to say display texture.set pixel, and we want to get the current position of the cell and the X and the Y, and we want to change it to the color black. All right. So that will basically get rid of it. Um, what we might want to do is, uh, yeah, I don't know if it will actually start off as having a texture of being black. So let's just do a for, let's just, we can actually, where is this? We can actually do this in here. So let's put this above here. So while we're looping through the grid, let's do display texture dot set pixel to the X and the Y, and we're gonna just set it to that color black. All right. And then after that, we want to say display texture.apply. Very good. So again, this will not do a whole lot right now. Um, then we want to kind of remove it. So when we remove it, we're going to say that this is black, and we want to say grid at that position. Actually, at the cell position, cell dot position dot x comma cell dot position dot y. We want to say that that's null because we're going to be probably using this to check whether or not there's something underneath it. So now, regardless of whether we're removing it or not, we are going to change the cell position. So cell dot position is equal to position, and we want to now set the pixel of the new position to the color of that cell. So cell dot color. So I just copy and pasted this one where we're going to get the cell position and change that. So I hope you're kind of following along so far. Again, we're creating a texture. We're creating a grid of the cells so that we can kind of store that. We have a list of all those cells. We are looping through, changing the color here, setting all that up, and then every frame, we're going to loop through all the cells and do some kind of logic for how the cells should behave. Then if we're adding any cells during this frame, we're going to add those cells to our list. So we're not looping through the entire grid. Then we would just want to clear out the ones that we've just added, and we want to then apply that texture. Um, and really, right here, when we add a cell, what we can do, well, we'll actually do this in a second. So in the set position, whenever we call this, we're going to send a position, send the cell, and whether or not we're going to change the last position or not to the color black. All right, so we have all that. Now let's create another script. All right, so I created a script called sand, and it's going to inherit from the set. And actually, let's do this. Let's create a public cell. Let's create a construct where we send it the let's just send it the int dot. Or actually, let's just send a position vector to position. All right, so here we'll just say uh, this position is equal to position. We could also send the color, but um, we're not because the script itself is going to determine that color. So right now we have a little squiggly line because we need to uh, add that constructor. So we've done that. Now what we'll do in this constructor for the sand, we're going to already define the color as being color dot. Let's just do yellow. Okay. So whenever we create the sand, this is what we're going to do. So right now we could actually go back and actually before that we do that, let's override that virtual one, activate, and we're not going to call the base, but in this is where we would have all the logic for sand. So let's just do kind of the start of it. So we're going to do a vector2, and we're going to call this down, and we're going this is going to equal our current position plus a vector2 int dot down. All right, so we're getting the down location of that. Now, before we do that, we do have a boundary for our simulation. We don't want it to go outside our bounds of the 100 by 100. So I'm going to create a little helper here, and we'll call it public. So I went back to the simulation, and we'll call it bool check bounds. So a lot of times when I make a game that uses grids, I will usually have this kind of helper. And we'll just send a vector to position, and we're going to return uh, false. But we will say if, so if position dot x is greater than or equal to 0, and that position dot y x is less than the width, and if the position dot y, this could all be on the same line of code, but um, I like to separate that. If the y is greater than the 0, and whoops, position dot y is less than the height, then we're going to return true. So we know we are inside our bounds for our grid. Um, and that will be useful for when the sand. So basically, when the sand falls, it's going to check first: have we gone too far? If we've gone too far, we're going to just stop. We're not going to do anything. So first, we're going to say if, and we're going to call our simulation, and this is where we use that instance. So now we have access to all of these, to anything that's public in our simulation. There's different ways to do this. If you don't like uh, what do you want to call these? Singletons. You can always use like event systems, but we're just going to use a singleton. All right, so check bound, position, and that's all we got to do. So now that we check to see if it's in bounds, we're just going to check to see if simulation.instance.grid, and we're going to check our grid, and we're going to check. Now I could always put this, if I'm using this a lot. All right, maybe we'll do that so I don't have to keep typing this code over and over again. So one thing, if you're kind of new to programming, or maybe you're kind of intermediate, it's always good to kind of save time to um, creating like helper methods. Or I don't know if there's a method or a function. Maybe I think a function returns something a method doesn't. But anyways, we're going to return bool. We're going to say check grid null, because we might be using this quite a bit, and we're just going to send a vector to position. So we're going to send it a position, and we're just going to say if grid position dot x comma position dot y is equal to null, then we're just going to we're going to say return true. Else we just, and we don't really need to do the else, but we can just say return false. All right. So this is just a little helper one, so I don't have to keep typing this over and over again, because we'll be using this quite a bit for a lot of our logic for different particles. So instead of doing that, we're just going to say check grid null for that down position. So we'll just say down. All right, so if it's null, that means there's nothing there. Hey, let's set a new position. So we're going to say, actually, hold up. Let's see. How about in our cell, we will make another little helper thing called void, and we'll just call set position, all right? And we will vector 2, and we're going to say new position. All right, so I think from here we'll just, so we don't have to keep typing simulation.instance, whoops, not instantiate, simulation.instance. We'll just have this do it. So new position, and let's just say bool is remove. Okay, so we're going to say instance dot set position, and we will send it that new position so we're not confused with our current position, and we will just send our this as the cell, and we will say is remove. Okay, so we'll have this so we don't have to keep typing that over and over again. I mean, we kind of do, but we kind of don't. So here, let's go back to the sand. So back in the sand, let's let's say set position dot no dots. Set position, we're going to say down, comma remove, we're going to say true. So we do want to remove the old one. So right now, all this will do is just it will keep going down. If it hits something, then it will stop moving. All right, so a whole lot isn't happening right now, uh, but we have everything kind of set up. Now let's go to our mouse painter. And so what are we going to do here for the mouse painter? Now we can actually attach this to that quad as well. And we want to, actually, do we need to do that? Maybe not. Let's see, how are we going to do this? We want to have a private void uh, check mouse. Okay, so let's do a if statement get mouse. Let's see, if statement input dot get mouse button 0. So if we do the 0, get mouse 0, get mouse button 0. We're going to call this check mouse. Now, what do we want to send it? Now, we want to send it a cell type. And here we're just going to say cell type is sand. So we're going to be adding the sand. So whether we're adding sand, whether we're adding water, this code right here is going to place that. So the way we do that is we need to send a ray from the camera to the screen, and we're going to check to see if there's a collider. And then if the collider is there, we are going to kind of figure out the exact point where we hit the collider. And now what you might want to do is Google this, because I didn't know how to I always forget how to do these kinds of things, so it's always good idea maybe just to Google it and to kind of figure out how to do that. So I'm going to kind of type in some code here real quick. All right, so let me just kind of go through this really quick. And sometimes it's different if you're using 3D versus 2D. I'm using 3D right now, so we're going to have a raycast hit, which is going to collect the data for colliders, and you use the physics.raycast, and you're shooting from the main camera, screen point array, and we're using the mouse position, so where the mouse is currently at. And we're going to, whatever we hit, so that collider that we hit, we're going to uh, out that into the variable that we named hit. We're going to just check to see if we actually did get a collider. So, and then if we do have that, we then create a vector 2, and we're going to get the hit dot, the texture coordinate of where we actually hit it. And then we want to multiply that by the width and the height um, of our simulation, which would be it's also going to be the width and the height of that texture as well. So then from there, we want to say simulation dot instance dot add cell, and we want to send that position. So that would be a pixel UV, comma, cell type would be that cell type that we're trying to send it. All right, we're getting a little squiggly line here is because we need to actually send a vector 2. So we're going to say new vector 2. Now, for this, we don't really need to round the decimals or anything. This will work just fine. Dot x, comma, pixel, dot y. This will work just fine. Okay, why isn't that working? Oh yeah, we gotta make these ints because those are floats. So now we've converted those to integers. All right, so this might be working. We're going to see. So just kind of go through it again. This is the paint, and we're going to check to see if we actually click the mouse button. If we do, we're going to call this method and send it the type that we wanted to create. So in this case, we're going to create a sand. We're going to send out array from our camera to the screen. And if we actually hit a collider, then we're going to get the actual text coordinate, but multiply it by the width and the height. So we kind of get that like resolution basically of the texture there. And then we're going to we're going to call this method add cell, and we're going to send that position, send the cell type. So then in our simulation, in the add cell, we have to now actually add the cell, right? So we're going to say um, sand is equal to new sand, and we're going to send it that position. Okay. One thing that I should probably do too is let's go to our cell. Let's just do this. Let's have a public cell type. Call it cell type. And the sand can just say cell type. Whoops. Cell type is equal to sand. All right, so that we're setting that cell in case we ever need to check. All right, so we're going to create that new sand, and then we're going to say uh, set the position. Now, what we could do here is say, well, no, let's do this. We're going to say cells to add, and we're going to say the sand. Whoops, we got to say cells to add dot add. We got to add to the list. All right, so we're going to add that list. And then what we're going to do actually, when we're looping through all the cells we're adding, let's set the position. We're going to say set position, whoops, cell or add cell. This way we can see the pixel right away. Um, hold up, dot position, comma, we'll say the add cell, comma, and are we removing it? The answer would be no or false. So we do not want to remove its old position because it doesn't actually have an old position. All right. Well, it would technically, the old position would be really the vector, or actually this right here. So, all right. So that's that. So I think we have everything now. Um, so this is how we're going to add it after we call it from the paint, add the cell, And then once when we have that cell, then when we loop through on the next frame, it'll be in this list of the all cells and it's going to activate it. So then when it activates it, it'll go to the sand and it'll run this logic of checking whether down position is in the bounds and the grid does not have anything, a current cell in it. And then we're going to just set the position to this cell with the correct color. So let's see if this is actually working. All right, so what we need to do on our quad, and let's just call this simulation display, I guess. Okay, that's all fine. Then let's go to add. We're going to add the simulation, and we're going to add the uh, mouse paint. Okay, and let's see if this works. I think before we do that, let's get our camera to kind of zoom in a little bit. All right, so that's pretty good. And let's run it. Let's see what happens. Let's maximize it. All right, so let's see if this works. All right. Ooh, we got a index problem. So let's just check that code. We do see the sand was moving down, but let's see what we have wrong here. All right, so I noticed here that I was calling the position, and that's not what I want. I want the down instead. So let me change that. All right, here we go. Let's click. And there we go. Look at that. We got sand. If I just hold in one spot, uh-oh, it's not actually working. So it is filling in the bottom area, but it's not stacking up. So let's see why it's not stacking up. And it keeps going. All right, so when I am setting the position, I also need to say that this grid, we didn't set the grid and say, hey, you need to be this cell now. So let's see if that fixed it, because it was still being null. All right, look at that. Pretty pretty cool. Now again, it's just stacking straight up. One thing though that I need to check is when I click, am I clicking? Um, I need to make sure that this is null wherever I click to, but that's kind of cool. It's stacking up. All right, so in our simulation, let's just add a little code here. If uh, grid uh, position dot x comma position dot y is not equal to null, then we'll just return. Don't even bother doing anything in this code because we cannot add a cell if we already have something there. We can't add. So basically, no two things can be in the same grid. All right, so that's done. But let's kind of fix our sand here. So our sand is checking for the down, but now we want to. What if it wasn't down? So we want to do an else statement here. And now we just want to check if we can go to the left. So we're going to do another vector2 int. We're going to call it left equals position. We'll do the same thing plus vector2, and we're going to say to the left. Now, if we're going to check if it's null. So simulation dot instance dot check grid null. And if this is left, then we're going to set the position. And we'll say left, and we'll say true. All right, now what we could do at this point, we might say, hey, this is not super efficient here because we keep retyping the same thing. It would be nice to uh, just see if we can add anyways. And maybe we need to add because this is pretty much the same as this here, right? We check if it's in bounds, and really even this we need to check in bounds. So we need to check if it's in bounds, and then check if it's not. And what we could do on our cell is maybe we do public bool, and I'm just kind of making this up right now. Public bool check placement, and we'll send the position. Sorry, vector2 position, and we want to say. I think that's it. I think that's all we really need. Just check that position. So let's go back to the sand and copy this here. All right, just do like that. But instead of down, we want to just say position. Now we might want to change this to maybe, well, we'll see. We'll see if we need to change it at all. Let's see what's seems to be the problem. All right, we want to return false. Whoops, false. And we want to say return true. Okay. So now we don't have to keep typing that over and over again. So let's go back to our sand and let's see if we can do this then. Instead of this, we're going to say, actually all of this, right? So right here, we can just simply say uh, check placement down. All right. And so, and we can actually do the not. So if we weren't able to go down, oops, let's get rid of this. Oh, what's all that? And delete all this. And delete this. All right, so if we weren't able to go down, then we will check left. So left, vector2 left is equal to position plus vector2 int dot left. And then we want to say if not check placement, and this time we'll do left. So if we can't do the left, if we could, we're going to place it. If not, then we're going to do one more check. If not, check placement is left. Or sorry, we need to say vector2. We're going to check the right. We're going to check the right, and we actually just can. Nothing's going to be inside here. So that doesn't really matter, but we're going to just check all those. All right. So now let's see if it's still working and maybe we have this kind of like pyramid type of sand placement. So, all right, we're back in Unity and let's just see if this is working. Okay, whoa, look at all this. Okay, something is not right. It's kind of cool though. This is almost like the water, but whoa, look at all that. Okay, this is definitely not working, but it's still kind of neat. All right, let's figure out what's going on. So I think the problem is I'm just checking to the left. I need to check vector 2 and down. So I need to add the down to the left. So let's just check the left first and see if that's working. All right, so you can see now we do have the left, so that's working pretty well. Let's that's kind of cool, right? We kind of already got it. Yay! But it's only going on one side, so let's get the right side. All right, so for the right side, we will just add that vector 2 down for it as well. All right, let's see if this works. Look at that. Cool. And you can kind of see my stats here. It's kind of going slow. That might be because of I have my OBS running. But yeah, it's looking pretty cool. Now, there's a little bit of this, like seeing the bottom of it here. So let me just uh, change this, and it looks kind of like blurry a little bit. All right, so right here, we'll just say that the display texture dot filter mode, and we're going to give it the filter mode of point. So it shouldn't be blurry, and I don't know about that top line. So let's go back. All right, there we go. We still see a top line up there. So maybe I need to check the scaling of this. But anyways, this is pretty cool. You know, you can just play around like this and drop all this sand. All right, look at that. So we were able to make a sand simulation. I might kind of stop the video here. Maybe we'll do a part two and add water. Now that we kind of have it all set up, we can start adding different particles to this, and see all the different ways that we can make this. So I hope you're enjoying this. Man, I could probably do this forever. Um, and seeing a way to do this kind of simulation using textures and pixels and a grid, and really it's running pretty smooth here. So hope you enjoy this, and any comments about maybe this is how you would have done it. I'm not saying that this is the exact way to do it, but this is how I did this, and maybe you have a better way of doing it. You can always leave some comments, and maybe if you want to see, what kind of other particles can we make here. In the next video, I'm going to add some water. We'll eventually do like lava and walls and maybe gas and just different things to kind of add to the simulation. All right, thanks again for watching, and I will see you next time. So long.